Welcome to homework.
Suppose that we have a three-state Hamiltonian whose matrix elements relative to certain bases are given over here. That is, H is equal to 1, 0, 0, 0, 2, 0, 0, 0, 2. We have also two other observables, A and B, represented by the following matrices. Over A is equal to lambda 0, 1, 0, 0, sorry, 1, 0, 0, 0, 0, 2, and B is equal to mu 2, 0, 0, 0, 0, 1, 0, 1, 0. Fine. So where lambda, omega, and mu are positive real numbers. So number part A is that we have to solve for the eigen values of H. So that is E1 is equal to AW, E2 is equal to E3 is equal to 2HW. And the eigenvectors would be AH1 is equal to 1, 0, 0. AH2 is equal to 0, 1, 0. H3 is equal to 0, 0, 1. Now for A, the eigenvalues can be determined as A negative A times I is equal to 0. So this means that when we'll plug in, we'll get negative A lambda 0, lambda negative A 0, 0, 0, 2 lambda negative A is equal to A square 2 lambda negative A negative 2 lambda negative A lambda square, and that is equal to 0. So this equation can be written as 2 lambda negative A times A square negative lambda square is equal to 0. So this can be written as 2 lambda negative A negative lambda, A positive lambda is equal to 0, and from here we'll get all of these terms in the parentheses. So A1 is equal to 2 lambda, A2 is equal to lambda, and A3 is equal to negative lambda. So the next step is that the eigenvectors can be found as is equal to this. So note that this is the eigenvector. So we have lambda 0, 1, 0, 1, 0, 0, 0, 0, 2 times alpha, beta, gamma is equal to alpha, alpha, beta, gamma. Fine. So from here it yields that lambda, beta lambda beta is equal to A times alpha. Lambda alpha is equal to alpha beta, and 2 lambda gamma is equal to alpha gamma. Now solve these equations using A1, A2 and A3. First we substitute A1, that is equal to 2 lambda, and then solve for alpha, beta and gamma in order to write the eigenvector as lambda beta is equal to 2 lambda alpha, and beta is equal to 2 alpha from here. Now then we have lambda alpha is equal to 2 lambda beta. This yields that alpha is equal to 2 beta, and over here we have 2 lambda gamma, that is equal to 2 lambda gamma, and from here we conclude that alpha is equal to beta is equal to 0. So it means that the eigenvector is A1, A1 is equal to 0, 0, 1. Now for A2 is equal to lambda, we get that lambda beta is equal to lambda alpha that implies that beta is equal to alpha, and lambda alpha is equal to lambda beta, that implies that alpha is equal to beta. And lastly we have 2 lambda gamma, that is equal to lambda gamma, that implies that lambda is equal to 0. So this gives us the eigenvector for A2 is equal to 1 over under root 2, 1, 1, 0. So fine. So the third step is that we have to solve for A3 is equal to negative lambda. So for that we get that lambda beta is equal to negative lambda alpha, that implies that beta is equal to negative alpha. Then lambda alpha is equal to negative lambda beta, that implies that alpha is equal to negative beta. Then we have 2 lambda gamma, that is equal to negative lambda gamma, and this implies that gamma is equal to 0, and the eigenvector A3 is equal to 1 over under root 2, 1, negative 1, 0. So this is for A. Now we have to solve for B. So now for B, the eigenvalues can be determined as B minus B times phi is equal to 0, and over here we have parenthesis 2 mu B 0, 0, 0, 0, negative B mu negative B, and this is equal to B squared 2 mu negative B negative 2 mu minus B mu square. This is equal to 0. I'm running out of space here, so I just try to write it over here. Now this equation becomes 2 mu minus B times B square minus mu square. This will become B minus mu plus mu, and you can write it as 2 mu minus B minus mu B plus mu is equal to 0. From here we have B1, that is equal to 2 mu. Then we have B2, that is equal to mu, and then we have B3, that is equal to negative mu. And now we have to find out the eigenvectors. So now the eigenvectors can be found as B, small b, that is equal to this. Now note that this is the eigenvector for B1 is equal to negative 2 mu. So we get that 2 mu alpha is equal to 2 mu alpha, mu gamma is equal to 2 mu beta, and mu beta is equal to 2 mu gamma. This implies that gamma is equal to 2 beta. This implies that beta is equal to 2 gamma. And this, all these three equations, these imply that beta is equal to gamma is equal to 0. So the eigenvector for B1 is equal to 1, 0, 0. Next, we have to find out at B2 is equal to mu. So for this, we get that 2 mu alpha is equal to mu alpha. That implies that alpha is equal to 0. Next, we have mu gamma. This is equal to mu beta. That implies that gamma is equal to beta. And over here we have mu beta that is equal to mu gamma. This implies that beta is equal to gamma. So this implies that the eigenvector for B2 is equal to 1 divided by under root 2, 0, 1, 1. Now for B3 is equal to negative mu, and we get that 2 mu alpha is equal to mu alpha. That implies that alpha is equal to 0. Then we have mu gamma that is equal to mu beta. This implies that gamma is equal to beta. And mu beta is equal to mu gamma. That implies that beta is equal to gamma. And this altogether implies that the eigenvector for B3 is equal to 1 divided by under root 2, 0, 1, negative 1. Now for B part, suppose that the system starts out in the generic state. So it means that is equal to C1, C2, C3, with C1 square plus C2 square plus C3 square is equal to 1. We need to find the expectation values at t is equal to 0 of H, A, and B, and we will find it by using this expression. So H and this becomes equal to the mass for this is, so this is the expression for H. Next we have to find out for A. So this is the expression for A. Now we have to find out the expression for B. So the expression for B is given as this. We found all of these expressions in the same method as we did in the previous equations. And now part C states that the system starts out in the genetic state by is equal to C1 H1 plus C2 H2 plus C3 H3. Now at T, the state becomes, so at T the state becomes equal to this. This is the equation, and we solved it, and we, after a couple of steps, we got this form. Now the for H, thus for H we get that H1 is equal to omega, P is equal to C1 square. H2 is equal to H3 is equal to 2 H omega, and P is equal to C2 square plus C3 square. So for A we have three eigenvectors. So A1 is equal to 2 lambda, and we can write it as A1 state at t is equal to exponential negative 2 iota omega 001 C1 times exponential I omega t C2 C3, and this is equal to exponential negative 2 iota omega t times C3. Thus P is equal to C3 square, and when A2 is equal to lambda, we get that the state is equal to exponential negative 2 iota omega t times 1 over under root 2 times 110 times C1 exponential iota omega t C2 C3. When we'll solve it, we'll get that it is equal to 1 over under root 2 exponential negative 2 iota omega t C1 exponential iota omega t plus C2. And when we'll solve it for P, we'll get that P is equal to 1 over 2 C1 square plus C2 square plus C1 star C2 exponential negative I omega t plus C2 C1 iota I omega t. So this would be the expression for P. Now we have in A3 is equal to negative lambda, so then the state would have this form, that is equal to exponential negative 2 iota omega t 1 over under root 2 1 minus 1 0 C1 exponential I omega t C2 C3, and this is equal to 1 over under root 2 exponential negative 2 iota omega t parenthesis C1 exponential I iota omega t negative C2, and for this we'll get the expression for P, that is equal to 1 over 2 C1 square plus C2 square negative C1 star C2 exponential I omega t negative C2 star C1 exponential I omega t, and this is the expression for B. Now for B we have three eigenvectors. B1 is equal to 2 mu, and we get that the state at B1 is given by B1. So for B2 the state is this, and the expression for P is given by this equation. Now we have to solve for B2 is equal to mu. So for when B2 is equal to mu, the state is given by, so the expression for the state is given by this expression, and equation for P is this. So now when B3 is equal to negative mu, the expression for state would be, so the expression for the state when B3 is equal to negative mu is given by this expression, and for P it is given by this expression. So this is your required value for B3, P and state.